We're on lesson 3 of chapter 3, which has us graphing using intercepts. So first we're going to find intercepts for a given equation, then we're going to use intercepts to graph an equation, and then we'll use a linear model. Here's the idea of intercepts. Intercept is just a fancy word for crossing. So when we have the x-intercept, it's telling you what is x when y is at 0. When we cross this 0 for y, what is x? When we find the y-intercept, we say what is y when it crosses that 0 for x, or when x equals 0. So for this example, y equals negative x plus 2, we could find the y-intercept by finding out what it is when x equals 0. So let's plug in 0 for x. Y equals negative 0, or just 0, plus 2. That would equal 2. So when x equals 0, y equals 2. You could do the same thing for y then. 0 for y equals negative x plus 2. Subtract 2 from both sides. You'd have negative 2 equals negative x. Divide both sides by negative 1. That would be 2 equals x. So when y is 0, x equals 2. And that's how we solve them. We plug in 0 for y and x to solve for the intercepts. Let's give that some practice here. Let's find the x-intercept and the y-intercept of the graph. 2x plus 7y equals 28. So if we're going to solve for the x-intercept, that means what is x when y equals 0? So we would make y 0 here. We would say 2 times x plus 7 times 0 equals 28. Since 7 times 0 is 0, then I'd have 2x equals 28. And then divide both sides by 2. And that would give us an answer of x equals 14. So when y is 0, x would be around here, 14. So if I were going to write that as an ordered pair, I would say 14 for x, 0 for y. Let's do this as the y-intercept then. If I'm going to write this equation, the y-intercept is when x is 0. So let's make x 0. We'd have 2 times 0 plus 7y equaling 28. 2 times 0 is 0, so we'd have 7y equals 28. Divide both sides by 7. And that would give us an answer of y equals 4. So when x is 0, so somewhere along this line, y would then be 4, and that's your y-intercept. If I was going to graph that out, I would say 0 for x, 4 for y, and there's our ordered pair. Now we actually can graph this equation just using the intercepts. Let's find that x-intercept, so when y equals 0, so we do x plus 2 times 0 equals 4, or just x plus 0 equals 4, or x equals 4. So here's our first x-intercept. So when y is 0, x equals 4, and we fill that spot in. Now we can find the y-intercept by making x 0. So 0 plus 2y equals 4, or just 2y equals 4 divided both by 2. That would give us y equals 2. So then when x is 0, y is 2. And then to graph these, if you connect the dots, if it's a linear equation, it's going to follow that same pattern with a line. So without any rise over run, without any extra work, we have just created our linear equation on the graph. This one's going to take us a little while longer, so we have to use a linear model to solve this. So a submersible, what we have over here, designed to explore the ocean floor, is at an elevation of negative 13,000 feet, so it's below sea level. The submersible ascends to the surface at an average rate of 650 feet per minute. The elevation E, elevation in feet, is given by the function E elevation equals 650 t minus 13,000, where t being multiplied here is the time in minutes since the submarine began to ascend. So our first task is to find the intercepts of this graph of the function and state what the intercepts represent. So let's do that. Here's our equation, right? E equals 650t minus 13,000. So if I want to find the e-intercept, what is e when t is 0? I can make t 0 here. So it would be e equals 650 times 0 minus 13,000. So it would be 0 minus 13,000, which would be negative 13,000. I'm going to write some numbers here and pause it. Alright, so I'm going to draw that in. Here's 0 for t. 13,000 is around here. So that'd be my intercept, my e-intercept. Now I can create a t-intercept. I'll do the same thing. Make e 0. So it'd be 0 equals 650t minus 13,000. So I could add 13,000 to both sides to get that over there. So it'd be 13,000 equals 650t. Divide both sides by 650. That gives me 20 for an answer. So t equals 20 when e equals 0. So here's e at 0, so then t would be 20. I'm going to write some numbers in for that too. So here's 0 for e, and here's 20 for t. So we actually can draw a line here to show the ascent of this submersible to the surface of the ocean. And that's what it's asking us here. What do these intercepts represent? So at 0t here, we're at negative 13,000 feet, and that's when we're at 0 minutes. So that means before we ascended, we were at negative 13,000 feet. E-intercept, that equals before ascent. Then what would this intercept be? Well, this intercept is after 20 minutes, where are we? Our elevation is 0. So the t-intercept, that's going to equal reaching the surface, because at the surface, that's when we have 0 elevation. We've already graphed this function, which number 2 is telling us to do. So now we need to determine the domain and the range. So the domain is the input, and the input here is always this x-axis, or t-axis in this case. So what do? We can't go below 0 because we don't have any data for that. So we started at 0 and we went to 20. So the domain would be 0 to 20. The range then would be anywhere from negative 13,000 feet, and then it stops at 0 feet. So range would be negative 13,000 to 0.